Hi guys. So I'm just gonna talk about what I learned, but actually, it's not really what I learned because I was not able to do really like productive thing, and I'm just gonna try to recap the the B tree, but also the final thing. But with the practical way, I already made the pull request of what I did. You can see here on this part. So I'm just gonna explain the thing. Actually, if it called quality in the perspective of quality, B-tree deletion was really difficult because I mean there's a lot of algorithm and data structure like B-tree and B+T, but whatever, and it's really easy when you just like when you just read when you just watch a YouTube that talks about those kind of algorithm. It's really easy, but if and also if you're like CS student, your professor you talk about like how does it works, and it's gonna be really easy to understand it. But implementation is really hard. I mean the implementation with think about the code quality. You can just implement just like copy paste all of the algorithm written in your language in the Google, just searching with your how to implement those kind of thing. But what I want to say is, but we are software engineer. We have to think about code quality, and that was really kind of tricky part because so I think about object-oriented program language, and I think that the class-driven code is equal to OOP, but it was not. So if you look at my code here, this is very slow. In B-tree, yeah. So if you look at, why is this really slow? Let's see. I think B-tree is gonna be here. B-tree. So if you look at this part, where this is really slow. So if you look at this part, all of those kind of logic like insertion and deletion search operation in this one class page, even though it is private, there's bunch of corporate code on here, and it does not really think about. It's not really flexible. Example, I want to get only the search part, but I cannot get because it is inside the class on the page, and it is also declared as a private method. So that kind of lead into a problem that when I try to implement the B-tree deletion part, that kind of lead me to have more cost on think about like on the implementation because the code quality was really hard, and the debugging time was really increased. So I'm just gonna I've refactored as a function based approach. Each function have minimal but has core responsibility on it. So but my experience not good, so I'm really not that good programmer because I already have only 9 months software engineering experience. So I'm also really student. I'm 22 years old, so I don't know I'm great or not. Whatever. So understanding part was kind of also it was hard, but it improved me a lot to write the even better quality code because B-tree implementation it was kind of hard. So I studied by myself rather than asking the professor because first of all my major professor was they are really making us to emphasize the memorization rather than understanding. Even though it is understanding, they didn't talk about the code quality and how to implement it. Example, the B-tree implementation could be easy, but it is not. You have to think about the pointers of it. Example, if you're trying to delete internal node, you have to think about the borrowing operation from the children. But you also think about the pointers of it because if you're borrowing from the children also under cause the underflows. So those kind of thing is really core thing rather than think about logic. But a lot of professors didn't talk about this kind of thing. I think this is because they have different way of what our software engineer did. Most of they don't have like software engineering experience, so I think that's kind of really different of professor in software engineering. But whatever. So I look at the most of like the reference was really the papers, research papers, and the like really high quality PDF or PP presentation from the outside of my country, which is Korea. Like China and the USA and China, they are really top class. Their explanations are really nice. But the B3 ubiquitous. I don't know how to explain this guy is really amazing. He talks about not just the algorithm of it. He talks about why we adopt a B-tree rather than focus on the algorithm like time complex part. The B-tree is also it uses the database using index algorithm of the from the bit like selecting the B-tree algorithm. But it talks about why do we have to think about the those kind of time complexity on the indexing or DB indexing, those kind of thing. And this research paper is explaining really well. So even like 11 years old kid can understand it. Even I'm a Korean. My English is not that great, but this vocab is really easy to understand. It's not really difficult. It's just really compact and simple at the best. So and next, so B3 delegation I just talked about in the last video of like B3 part, but let's skip up that. Next part is the implementation. I utilize the iterator, the design pattern, and also of the node object creating a page node. I use it the React Fiber system, and rather than like just a class based on it. So of the recursion, I really don't like recursion on the, especially on the B3 deletion, because you have to think about the background. You have to make sure there's pointers not only go to down. It has to be go to the top of it, because you're borrowing from the parent. Could be also make the parent underflow. So you have to think about the pointers. It has to be go upward, and so the B3, the fiber approach was really kind of I used this fiber approach. This approach was really nice, and because they also have the problem that the recursion wasn't a really good idea for the tree data structure, tree traversal algorithm. So I just did what they did, like using recursion and just using the simple pointer of it. So those kind of thing was really kind of easy rather than recursion approach. But the thing, my mistake was I didn't really think about the immutability in the JavaScript. JavaScript is a really high level language. You have to think about pointer, but so underneath that, the object reference is all the pointers. So I should have keeping myself think about the immutability of the JavaScript, but I didn't that. So I think the next PR I'm just gonna put all of the put some kind of making immutability approach. I'm just gonna refer the whole deletion part of it. So I think this is it. I'm just gonna paste this. I don't know you guys watch or not. I'm just gonna paste this kind of link on here. So you guys can see or not. So have a nice day. See you next time. Bye bye.